The masses m grams of bags of flour are modeled with this distribution. So the variance is 2.25, which means the standard deviation is that square rooted rather, which gives 1.5. I always think it's just good to write that by it so you don't accidentally put in 2.25 into your calculator. Then we're asked to find out this probability. Okay, well, everything's set. Our calculator is doing an integration. Let me just actually demonstrate what it is doing roughly. So we've got 1002 and it's finding the area here between 1000 and 1005. This can be written as a function. You may or may not have seen that, but in any case, that's what's going on to get the probability. So I'm going to be doing normal CD between 1000 and 1005. Got my 1.5 for my standard deviation and 1002 for the mean. And this gives 0.886. We're then given a different distribution. The masses in grams of bags of sugar are modeled by normal distribution with mean mu and variance sigma squared. And we have to work out what these are to 2 decimal places. But we're given some information. So I'm just going to bring this down a little bit. Okay, so I'm going to say now it's S follows this normal distribution, mean mu, variance, sigma squared. We're given that 20% of the bags have a mass greater than 502. So that means the probability that S is greater than 502 is equal to 0.2. And then 30% have masses less than 499. So S less than 499 is 0.3. Okay, we've got those two pieces of information. Now we're going to be using the inverse normal function in a minute, and to do that, I'm going to need to write it as S is less than for both of them. So less than 502 would actually be 0.8. That is the one I'm going to use. Just going to sketch these out. So here's my distribution, mean mu, less than 499. So that is going to be to the left is 0.3. And less than 502, so that's going to be to the right. So I know the mean is going to be between 499 and 502 just from this diagram. Right. Well, what we do is we standardize the normal distribution. We don't know the mean and the standard deviation, so let's make it so we do. I'm going to let Z equal S minus mu, because what that will do is mean that the mean of Z is 0, and then I divide by the standard deviation, and that actually makes the standard deviation be 1. Z is then the normal distribution with mean 0 and variance 1, standard deviation 1 as well. So this transforms things. So my top diagram, suddenly I know what the mean is, but this 499, I don't know what it is anymore. It's going to be 499 minus mu over sigma. But I can still write down the probability. The probability now that Z is less than 499 minus mu over sigma is still 0.3. That property has not changed. I've just transformed the distribution. And I do exactly the same with the second one. It's mu. Here now it's going to be 502 minus mu over sigma. The probability that Z is less than 502 minus mu over sigma is equal to 0.8. And I can use the inverse normal now. So that will get me 499 minus mu over sigma, and 502 minus mu over sigma inverse normal area. The first one is 0.3. And then remember, I'm using the standard normal now. So we get minus 0.5244. Um, 5244, might just add another, so 0. And then for the other one, 0.8, 0.84162. And I'll have some simultaneous equations to solve. We can times through by sigma. You could then add mu onto both sides and then put it into your calculator. To be honest, I think it's just going to be quickest to subtract them. So I'm going to do the bottom one minus the top one, which will give me 3 on the left-hand side. The mu's cancel, equals 0.84162 sigma minus 0.5244 sigma. Okay, so I've got this. Let me just store that. Then alpha A, then it'll be plus 0.5244, gives me 1.366. There's a 0 in there as well. Sigma. So sigma is 3 divided by that. 2.1961. And I can work out mu. So mu is going to be 502 minus 0.84162 times this value. Which gives us 500.15. Let me just, before I round it, let me just add a little bit more, 1/6. Okay, so now we round it. So therefore, mu is equal to 500.15. It did ask for 2 decimal places, and sigma is 2.20. Okay, this just takes a little bit of practice. I hope you're happy with that. Okay, in part C, we're then given the probability distribution of a normal variable, different one again. We're asked to write down estimates of the x-coordinates of the points of inflection on the graph. So remember, this is where the graph goes from being concave to convex or vice versa. It's where the gradient goes from, let's look to on the left-hand side. See, the gradient's, well, it's positive throughout, but it's actually increasing. Because look, here's some tangents. The tangents are increasing. But once we get to about here, it starts decreasing. So that is going to be a point of inflection, about x equals 0.5. And then it continues to decrease until we get to around here where it starts to increase again. I know it's negative, but it goes from being very negative to less negative. So it is increasing from this point onwards. So x is equal to 3.5, and those are our two answers. Just for reference, as long as you went anywhere between 0 to 1 and 3 to 4, you'd be okay. The next bit you need to use your answer for. So it asks us to hence write down an estimate of the standard deviation from this. Okay, now we have the mean is where the central part is. What you need to know, expected to know, is that where this point of inflection occurs is actually at the mean plus 1 standard deviation. And the other one is the mean minus 1 standard deviation. So really your values should have been either side of 2, like the same distance away. And what we find in my case is that the difference is going to be 3. Therefore, 2 sigma, because that is the difference between mu plus sigma, mu minus sigma, is going to equal 3. And therefore, sigma is going to be 1.5. I mean, it says explain your method. It's only 1 mark, but I need to kind of point this out. And I think I would write in words, I'm not going to do it here, but write in words that the points of inflection are at mu plus sigma and mu minus sigma. The difference is 2 sigma is 3, and therefore sigma is 1.5. That is the standard deviation.